Hello students, today we will be learning about the allotropes of carbon. Now carbon is found to occur in different forms in nature with several physical properties. There are some interesting allotropes of carbon that we will be learning about in this video. But before we begin, let us understand what does the term allotrope refer to. The term allotrope refers to the element that can exist in more than one physical form. So basically, allotropes are different structural forms of the same element. So basically, allotrope refers to the element that is able to exist in more than one structurally different form. Now, carbon is one element that is able to form many such allotropes. What is the reason behind this? That why is this versatile element carbon that is able to form many allotropes? It is because of its nature, that is, it exhibits two unique properties, that is tetravalency and catenation. Now, let us just briefly discuss this, as we'll be studying about them in detail in our next video. So, by tetravalency, we mean that as the word tetra means four, now we know carbon atom has an electronic configuration of 2, 4. So how many valence electrons does it have? It has 4 valence electrons, right? Now, as there are 4 electrons in the outermost shell, so it forms 4 covalent bonds by sharing its valence electrons with itself, or we can say with other atoms as well. Now that the valency of carbon is 4, it is said to be tetravalent. Whereas on the other hand, we have catenation as a unique property that is exhibited by the carbon element. And what do we mean by catenation? Now, catenation is the ability of carbon to form bonds with other atoms of carbon, thereby giving large molecules. So basically, catenation is the self-linking of atoms of an element through covalent bonds to give rise to chains or rings as well. So here we understood that why carbon is able to form several allotropes. It is because of two unique properties, that is tetravalency as well as catenation. Now, we have just briefly touched these two properties. We will study about these two properties in detail in our next video. Now, let us see what are some interesting allotropes of carbon. So we have diamond, graphite, Buckminster fullerene, carbon nanotube. Here in this video, we'll be taking up two of its allotropes, that is diamond and graphite. Now, diamond is one of the well-known allotrope of carbon. It finds its use in making jewelry like rings, necklaces. And why? Because of its lustrous nature as well as durability. Now, we know that diamond is the hardest material known. And so it finds its use in industries as well. Now, diamond possesses a giant covalent structure where we can see that each carbon atom is covalently bonded to 4 other carbon atoms. Now, the bond angle is 109.5 degree and the bond length between these two carbon atoms is 154 picometer. Now, these tetrahedral units join up together to give a large three-dimensional lattice structure, as we can see here. Now, have you ever wondered that why is diamond the hardest material known? That is, it is extremely hard. Now, it is because of the fact that it has a large number of strong covalent bonds. Now, this is a tightly held arrangement of atoms in a tetrahedral manner that makes the diamond hardest substance on Earth. Now, let us see if diamond can conduct electricity or not. Now, each carbon atom is covalently bonded to 4 other carbon atoms, as we can see here. This is the central carbon atom and it is bonded to 4 other carbon atoms. Now, all the valence electrons of carbon atom are involved in the covalent bond formation. Now, you can see each carbon atom has all its valency occupied. Why? Because they are all involved in the covalent bond formation. So, what does that mean? That means that there are no free electrons, right? There are no free electrons that can move through the structure to help conduct the electricity. And due to the absence of free electrons, we know that diamond will not be able to conduct electricity. because it is due to the motion of electrons that the conduction of electricity takes place. But now in the case of diamond, we just saw that there are no free electrons, so diamond does not conduct electricity. So, did you know that the flickering flame of candle contains millions of tiny diamonds? Now, this was the research conducted by Dr. Zhao, and he found that in the burning flame of a candle, 1.5 million diamond nanoparticles are made every second. But later onwards, it is found that the diamond particles are burned away and they're converted into carbon dioxide. So as of now, these particles cannot be extracted by any method or any means. Let's take up another allotrope, which is graphite. So have we ever wondered that what is the core inside the pencil made up of? It is made up of a mineral called graphite. Pencils comprise a form of solid carbon, which is known as graphite, that is another allotrope of carbon, and it is a black colored solid that is soft and slippery in nature. Now in graphite, each carbon atom we can see here is covalently bonded to 3 other carbon atoms. The bond angle in graphite is 120 degree and the bond length is 142 picometer. And the layers are stacked one over the other, and thus graphite can act as a lubricant. Now, have we ever wondered that why is graphite soft and slippery? Let's find it out. Now, this is the structure of graphite that we see here, that is arranged in layers where each carbon atom in a layer can be seen bonded to 3 closest carbon atoms. Now, this results in planar hexagonal rings, as we can see here, that are arranged in layers one above the other. Now, these layers are then stacked over each other. This gives us the layered structure of graphite. Now, the reason as to why graphite is soft and slippery in nature: the carbon atoms within a layer are strongly bound together. So when we talk about the carbon atoms that are present in layer, as we can see here, now there are strong covalent bonds between the carbon atoms in each of the layer. But when we talk about the forces with which the layers are bound, then these are really weaker forces that are holding up the layer together. Now, as a result, it becomes easier for one layer in graphite to slip past the other layer. And it is this slippery layered structure which makes graphite a suitable material to write with on paper. Now let us find out that does graphite conduct electricity or not. We know that graphite has a honeycomb-like layered structure and it comprises hexagonal rings that are arranged in layers. Now here we can see that each carbon atom is bonded to 3 other carbon atoms covalently. Now there is one valence electron of the carbon atom that is free, right? That is not used to form any covalent bond, because we know carbon is tetravalent and it forms 4 covalent bonds. But in the case of graphite, each carbon atom is covalently bonded to 3 carbon atoms only. So there is one free electron left with carbon atom. Now this free electron that we see here is free and can move along the layers to conduct electricity. Now, did you know that graphite is one of the most extensively used anode materials today, and it is used in commercial lithium-ion batteries. Now, graphite can reversibly replace lithium ions between its many layers. So before we learn more about this, let's just see what is graphene. So now this is the layered structure of graphite, right? Now when we talk about one isolated layer of graphite, then this is known as graphene. Now graphene is the isolated layer of graphite. Now what happens is that this is the graphene layers which are without lithium ions. Now when lithium ions get diffused between these graphene layers, the distance between the graphene layers increases, because there are weaker forces between the layers, right? As we just have learned. So lithium ions can very well easily diffuse in, and the distance between the graphene layers will increase. So this brings us to the end of this video, where we learned about why carbon is one element that has many such allotropes. It is because of tetravalency and catenation that is, it is able to form so many allotropes. And in this video, we learned about 2 of its allotropes, that is diamond and graphite. In our next video, we will be talking about Buckminster fullerene and carbon nanotube, which are another allotropes of carbon.